So, ladies and gentlemen, boys and girls, are we live? Yes, yes, we are live. Yo. Okay. Yeah, good evening. So, ladies and gentlemen, boys and girls, is everybody all right? I need to know in the live chat if you can hear me and if you can see me properly. Drop a thumbs up so that I'll get to know yes, everything is okay. Okay. Hi. Okay, so let the people come. Afterwards, we'll start exactly. Hi, what's going on? Okay. That's nice. Is everything fine? Can you just hear me and see me properly? Mm-hmm. Hello. Hey. Yes. Okay. So today we're gonna be basically talking about the superposition principle and some of the problems from superposition principle itself. And in the special class, we'll be talking about some beautiful problems, some good level problems. Okay, so I want you people to join me over there at exactly 8 o'clock. Okay, 8 o'clock will be our special class. So let the people actually join, then we'll start accordingly. Okay. So, boys and girls, this is the piece of information about me. My name is Yawar Manzoor and I'm a JEE Physics expert. And okay, good evening. So apart from this YouTube platform, we have our own platform that is I like your Apple Garden, sir. Okay, that's very nice. So apart from this YouTube platform, we have our own platform that is the Unacademy's own platform. Okay, over there you can basically take this plus subscription. So there are so many benefits that you're gonna get in this plus subscription. That is the live classes, weekly tests, structured courses, unlimited access. Means every single day you will see lots and lots of educators who teach you. Understand, there are countries next level, top level educators are basically teaching you over there. And we have this iconic subscription. In this iconic subscription, you're going to be getting all these benefits which you get in plus, and extra you will be getting this much, this personal guidance an educator will be given to you that will basically help you throughout your exam. How will you exactly crack that? And you'll be getting the test analysis once you are done with your test. After that there will be the analysis of that, where you are exactly lagging, in what portion you have to work more. And this is the experts guidelines, study material, study planners. Is everybody all right? I need to know in the live chat. Drop a thumbs up or something like that. Good evening. Okay, everybody actually feeling nice. So this is my username on Unacademy. You can definitely follow me over there because every single day we come up with lots and lots of special classes where we discuss the problems from different concepts. And this is my username on Instagram as well. On Facebook, you can definitely follow me over there. And you can take this IIT JEE Iconic subscription. If you take the subscription for 12 months, 18 months, and 24 months, you'll be getting the branded notes. Okay, definitely. Sir, please bring your questions of boards 2022. Okay, so in this plus subscription, you will be getting, if you take it for 12 months, you will be getting 2 months of extension. And if you take it for 24 months, you will be definitely getting 2 months of extension. Hi, what's going on? Okay. And you can take this plus subscription for 12 months, you can take it for 18 months, and you can take it for 24 months. Okay, by using my code you can definitely get the maximum possible discount. So prices are basically listed over here, how much this is for exactly, how much this is for exactly. Okay. Our Sir OP is back. That's nice. And this iconic subscription, you can definitely take it for the 12 months. You can definitely take it for the 18 months and 24 months as well. By using my code, you can get the maximum possible discount. By using my code, you can get the maximum possible discount. And these are the prices which are listed over there. You can take it accordingly. Understand? And we have this beautiful feature on Unacademy, Ask a Doubt. If you have any sort of doubt, you can just click a picture, upload it on Unacademy. You'll get the solution within no time, because our educators are waiting for your questions only. And these are few of the batches which are running in Unacademy right now. You can definitely enroll in any of these batches. This is the Unacademy's Combat Scholarship Test. You can go for this one, and if you get the rank like this from 1 to 3, you'll be getting 1 year IIT JEE subscription for free. To unlock this one, use my code YAWAR. Okay, fine. And this is the one more scholarship test. You can go for this as well. And if you find any of my content as inappropriate, you can definitely report over there. So ladies and gentlemen, we will be starting with the vector form of Coulomb's law. Okay, till now we saw the Coulomb's law, the magnitude of Coulomb's law. Or if there is a charge over here, there is another charge over here. This is basically applying some sort of force on this one, and this is also applying the force on this one. So we calculated how much force that is. F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. Understand? Yes, yes, yes. Okay, hey. Now, so today we're gonna be basically seeing this Coulomb's law in vector form, because we see the force is a vector. Okay, so it will have the direction, it will have the magnitude. Understand? Whatever we basically represent in the vector form, we have to show its the direction as well, we have to show its magnitude as well. Like, see, for example, there is a vector over here. If I tell you, you have to represent any quantity in the form of a vector, or you have to show its vector form. So what you have to basically show, you have to show its magnitude, how much it is actually, how much is the quantity, and what is the direction. Okay, what is the direction? You have to basically go for these two things, then only you will get the vector form of that one. Similarly, we're going to be talking about the Coulomb's law in the vector form. I'll be showing you the two methods. That will definitely take the confusions out of your mind if you have any sort of confusion in this one. Now see, for example, I have this charge Q1 over here. We have this charge Q2 over here. We know till now this charge, if this is a positive charge and this is a positive charge, same charges, okay, not the opposite one, like charges are present over here. So this is basically applying some sort of force on this one. Can I call that in this direction, in the opposite direction, because like charges repel each other? So can I say that that force is basically, I would say that is the force on second charge due to the first one, that is F21. See, in this direction, rightwards, definitely. Now if I talk about this charge over here, this charge will also be having some force because of this one. This will apply the force on this one, so there will be the force in this direction. Can I call that F12? That is force on first charge due to the second charge. 100%. I hope everybody is understanding. And if I say the separation between these two is nothing but R. Now, what if I ask you to tell me how much is this force exactly? We have calculated this in the last class. Today I'm asking you how much is this force exactly? You will say simply this force is nothing but, because Coulomb has already told us how to find this force between these two charges. So we know that if I talk about this F21, if I talk about this F21, it is nothing but, that is K. K is equal to 1 by 4 pi epsilon naught in air, okay, and this is Q1 and this is Q2 and this will be here, this is R square. Fine. So this is the formula, this is the magnitude that we have studied in the last class. Right now this is only the scalar form, there is no vector form. This is not basically indicating any sort of direction. This is not showing us in which direction this force exactly is. Now what we need to exactly do, magnitude we have to basically attach the direction to it, then we got the vector form of this force only. Understand? Now how do we exactly do that? let me just tell you a simple concept that you might have studied in your kinematics when you were in class 11th. Let me just recall that concept. For example, if I'm traveling from this point and I have to travel to this point, okay, I'm traveling from this point, I'm reaching this point. This is a simple thing I'm telling you right now, okay? For example, if I say over here my displacement is S1 or my displacement is over here S2, understand? Position S2, S1, S2. Now if I say how much a displacement I have traveled, you will say this much of displacement you have traveled. So if I say how much exactly, you will say simply final point minus initial point, S21, or you will say S2 minus S1, final point minus initial point, that is this much. How much is the change in displacement, understand? Now, if you say you have traveled from this point to this point, what is your direction of displacement? You will simply say, if I'm saying S2 minus S1, that means I'm going in the right direction. I have basically traveled this much of distance. That this was the direction of my displacement. Understand? Exactly, I can say it like that. Definitely, yes. Same is the case over here. If this R is the radius, or if this R is the separation between these two charges, if I ask you, will this R have any sort of direction? Yes, this is a radius. This is the radius vector over here. This will have a direction. Now, here also you will use the same concept. If you travel from 1 to 2, if you go from here to here, then in that case, you will say simply, here it is R2, here it is R1. You will say simply, this is R21. Simple case, this vector in that case, understand? Now this R21 will have same direction as this force F21, understand? See, R21 I am saying right now over here, I can also say this R12 also, that will have this direction. That means if you are going from Q2 charge to Q1 charge, and if you are moving from Q1 to Q2, then you can say final point minus initial point. If you are moving from this to this, then you will say final point minus initial point, that is 1 minus 2. Yeah, one and the same thing, man, okay? So this is how we find the direction of this displacement, this radius vector. Exactly, understand? Now, we got this radius vector that is in the direction of this force. Now, I'm asking you to tell me the vector form of this force which is having the direction as well as magnitude. Magnitude we have got over here. Now, how to find the direction? See, we have to find the direction of this force. That means we need to find that unit vector which is along the direction of this force, because unit vector we use for the direction purposes only. So we'll put the unit vector over here. That unit vector will tell us the direction of this force exactly. Everybody is understanding this one? I hope everybody is understanding this one, okay? Come on. The people are actually absent today, okay? I don't know why. Okay. Now, so what I am saying right now, what I am saying exactly right now, yeah, direction of unit vector for F21 is, yeah, exactly. I'll tell you exactly. I'll tell you what it is exactly. See, so we got this magnitude. Now we have to put out the direction also. For that, we'll use the unit vector. So what is the vector which is along the direction of this one? That is this R2. We can take this one. So we have to basically take that unit vector of this one only, because this radius vector is having the same direction as this F21, understand? Now take the unit vector of this one. Can I say unit vector of this one? That will be nothing but R21, this unit vector. The magnitude of unit vector is nothing but 1, so we'll get this back, understand? So not a problem if we can introduce this one. Now if I say you, how do we exactly represent this unit vector if you have basically studied in your vectors in your class 11? Can we say this unit vector, if I say, for example, I have this unit vector A, how do we represent this? Vector A upon magnitude of this vector A, exactly. Now, can we represent this also like this? So this will be R21, understand? So can we say R21, this vector and magnitude of R21, this magnitude, understand? So magnitude of this R21. So instead of this, can we put out this over here? Then we'll get the formula exactly. So F21, I'll just write over here. So this will be nothing but K. This will be Q1, Q2, and this will be R square. Instead of this unit vector, I can put out this one. So this will be nothing but R21, this vector, and over here it will be R21 exactly. Understand? Can we write it like this? Everybody send me the thumbs up in the live chat. R12 is basically this unit vector. Understand? R12 is basically this radius vector which is along this direction. When we talk about is R21, that means you are traveling from this point to this point. That's why final point minus initial point. That's why R21. Over here you will say F21 also force. Okay? When we find this one, this F12, at that time we'll take this unit vector which is along the direction of this force only. Drop a thumbs up. Yeah. See, you might get basically the confusion over here. Some books will take this R21, some books will take this R21, but it doesn't matter. What the concept I am saying, you take that only. Understand? Keep that thing in your mind. Okay, I'll show you the other method also. So don't get basically confused. If you see in any of the books, because different books have the different languages, take this one only. See, if we are traveling from this point to this point, say final point minus initial point, that is R2. If I say over here radius vector is, over here the position vector is R2, here it is R1. So it will be R2 minus R1. That means you have traveled this in this direction. That means you have traveled in this direction. Different books will have different languages. Okay, I'll tell you all the cases. Don't worry about that. Okay. Hey, some books will basically, if I say R21, some books will write it is nothing but R1 minus R2. Some books will write it R21 is nothing but R2 minus R1. Understand? But what we should exactly know, what is the concept behind this? The concept behind this, if we got that one, that means whatever you have to basically write over there, it doesn't matter. You just need to understand the concept. Okay? So no need to worry about at all. Just whatever I am saying you over here, take that. It is 100%. This will help you in solving any of the problems. Come on. Yes. Okay. That's nice. Chalo. So now what is this R square over here? Instead of this R, we already took this R21. Can I basically write it? It is nothing but F21 is nothing but this will be K Q1 Q2 upon. Instead of this, I'll take this one because we have already moved from this point to this point. We are taking the vector, we are taking that radius vector which is along the direction of this force. So that is nothing but R21 and its square exactly. So this is, I'll just rub it, write it once again. This will be R21 and its square exactly. And if we multiply this with this one, understand? Because this is also the magnitude, this is also the magnitude over here. If we multiply this magnitude with this one, will it becomes cube? Definitely it will become cube. So I'll write, and this will be over here R21, its vector. So finally we got this one as this is the vector form of this force which is along the direction of this one. Understand? Everybody got the feel of this one? It's okay, it's okay. It's okay, not a problem. We just started. You got the feel? Drop a thumbs up if you understood this one. Okay, now we'll use the basically same approach in order to find this F12 force. Understand? If we call this as F12 force, we'll use the same approach. We'll use the same approach. Now, let's move on. See, this is basically the vector form that we derived, that we just derived. Okay. Okay, everybody got the feel of this one? Yeah, that's nice. That's nice. Now, similarly, we can basically find the another one also. Similarly, we can find this another one also. Same. But instead of this R21, we'll be taking R12. Rest, everything is same. You have to do this only. Understand the same approach you will be using for this one. So you will be getting that one. What is this R12 in that case? R12 is basically telling us this is the radius vector which is along this direction. So we'll take the unit vector of this radius vector. We'll take the unit vector of this radius vector because that is along the direction of this only, towards the left. So that unit vector will give us the direction of this force also. Understand? Like we exactly did over here. So instead of, so for this, can I say it will be nothing but, so that force, can I say it will be nothing but F12? Just put the vector over here. Can we say this will be nothing but, it will be K Q1 Q2 upon R12 its cube, and it will be R12 vector over here. Everybody got the feel? Everybody? I hope so. I hope so. Chalo, let's move on to the, so we got the another one also. So we can basically write that F12 is nothing but KQ1 Q2 upon, that will be R12 cube and R12 its vector exactly. Come on. There is the another way also. There is the another way also. Now see, let me just show you in just few seconds. Okay, so we say basically this is the charge over here. We say this is plus Q, and we say this is the another charge. This is plus Q2. For example, if I say Q1, this will be plus Q2. And this radius between these two is R. Okay, we say this is applying the force. Khushi, I suggest you to stay active from now onwards. Okay, this is the another method of vector form of Coulomb's law. You will get to understand from this also. That one was the first method. This is the second one. Some books write it like this also. Understand? So let me just show you. So the force on this charge, because of this charge, I would say that is nothing but same F21. Force on second charge F2 due to first charge, that is 1. Okay. Now over here, I will write it is F12, force on first charge due to the second charge. Understand? These are the two forces over here. Now if I say over here, how do we exactly find that vector form? So first of all, we'll write the common form, that the scalar form. What is the scalar form? How much force this is applying on this one? We have studied this in the last class. That is nothing but K Q1 Q2 upon R square. Understand? This K Q1, K is 1 by 4 pi epsilon Q1 Q2 upon R square. Understand? Now I'm asking you, what is the unit vector which is along the direction of this force over here? Understand? See, can we write, if you are traveling from this point to this point, if you are traveling from this point to this point, so can we say the radius vector will be simply, that is nothing but R2 minus R1, because over here, as I told you previously, if you are traveling from this point to this point, over here if displacement is S1, over here is if displacement is S2. If I say how much is the change in displacement, you will say simply that is S2 minus S1. Final point minus initial point. This is telling you have traveled from this point to this point. Understand? Fine. So same we're gonna be doing over here. If this is the radius between these two, this is a radius vector between these two. If you're traveling from, if you go from Q1 to Q2, in that case, we'll take this radius as R2 minus R1. So this will be nothing but the vector, the radius vector along the direction of this force only. Understand? So we'll take this one simply. Now, in order to find the direction of this force, in order to find the direction of this force, what are we gonna use? We'll take the unit vector which is along the direction of this force. So what is that? We can take the unit vector of this radius vector, because this radius vector is also in the direction of this force. So what is the unit vector of this one? So can we take that is R2 minus R1, its unit vector exactly. As we know, how do we represent the unit vector? A unit vector is nothing but vector A upon mod of this A, 100%. So can we represent this like this only, R2 minus R1? It will be nothing but, it will be R2 minus R1. Its vector and magnitude of R2 minus R1 over here. Now put it over here, we got the vector form. So can we basically say this is F21 is nothing but, so it will be K Q1 Q2 upon, instead of this R square, we changed it to R2 minus R1, because we are moving from this point to this point. That's why I am saying we took this radius vector which is along the direction of this force. That's why instead of this, I can write this one also, because this is having the direction as well. We need to find the Coulomb's law which is having the direction as well. Now, so instead of this, I can write R2 minus R1. Its magnitude over here, and it's square, because this is square over here. Understand? Now, so instead of this, I'll put this. So can I write R2 minus R1 over here, this vector, and this will be over here R2 minus R1, its magnitude exactly 100%. Now multiply this with this one, we will get the F21. We can basically put it in this one, in this form. 1 second. I'll just write it over here so that I'll be able to make the box afterwards. So I'll write F21 exactly over here. It will be nothing but that is K q1 q2 upon, this will be r2 minus r1 its whole cube, because we'll multiply this scalar form with this one, and then we can take r2 minus r1 its vector exactly. Now I'll just put it in the box. So this is basically the vector form. Some books write it basically like this also. Either you can take the first one or you can take the second one. It's one and the same thing. Similarly, if we want to write if we want to write this force in the vector form, in that case, what we are supposed to do, we'll take the radius vector which is along this force only. Which one? That is r1 minus r2, because in that case, you are traveling from this point to this charge to this charge. So final point means initial point. Final radius position means initial radius position. You can say it basically like that also. So that will give you this one also. We can say it like that. Now let me just make that over here. This will be f12 vector. It will come out to be k q1 q2 upon r1 minus r2 its cube and r1 minus r2 its vector over here. So this is basically that the magnitude as well as a direction of the another force which is acting on this one, which is acting on this one. Yeah. If you could understand this properly, then everything is easy. Yeah. Do let me know in the live chat if you got this properly. Drop a thumbs up. What square? Hari, what square you are talking about? This square. You are asking me basically, why is this cube over here? Huh? Are you asking me why is this cube over here? This is a vector form basically. Understand? See, we multiplied this magnitude, we multiplied this unit vector with this one. So in this unit vector, we can represent this unit vector like this. So it is basically r2 minus r1, the magnitude. So I multiplied this magnitude with this one. So that's why it's cube over here, and this is a vector form. That's why you'll get this one. r1 minus r2 minus r1 square. Where exactly? Everything is clear? Yeah, that's nice. Chalo, let's move on to the next one. Now we have this principle of superposition. What is this principle of superposition exactly? Can you guys tell me? Let me just give you the feel of this principle of superposition. Okay, clear, sir. Can you just write me in the live chat, what is this principle of superposition exactly? I need to check my Wi-Fi. Is it on 5G? Yeah. 5G is connected over here. Come on. Can you guys tell me what this superposition exactly is? Principle of superposition. Let me just give you the feel of this one. This principle, superposition principle. Let me just give you the feel. See, I'm saying that, for example, if there is a charge present over here, understand? If I say, for example, or I'll take this charge, okay? If I say, for example, there is a charge present over here, this is the charge, exactly, this is the charge present over here. I would say, for example, this is Q. And I am bringing one charge over here, that is what we call the Q1. Now, if I ask you the simple question, what's going to happen with this charge if I bring this charge nearer to this one? You will say simply, sir, this charge will basically start repelling this charge if both are positive. If this is negative, this is positive, then it will attract. So for example, if I'm saying this is positive, this is positive. So this will start applying the force on this charge. I would say this F is equal to 10 Newton. Understand? For example, if I say like this, understand? I'll make you understand this superposition in a very, very, very beautiful way. Okay? Now, if I say, for example, I'm taking this charge once again, I'm placing it over here, and I'll say, I'll keep this charge on the other side. Okay, this is basically, these are the individual experiments that I'm doing. So now I'm taking this charge over here, the same charge Q, I'm bringing the Q2 over here. Understand? Q2 over here. In that case, what's gonna happen now? Again, this will start applying the force on this one. For example, if I say this is applying the force of 20 Newton on this one. Understand? Fine. Now, I'll take this once again, the same charge, and I'll place it over here, and I'll bring this Q3, And what's going to happen, this will also apply the force on this one. If I say, for example, this is applying the force of, for example, 30 Newton on this one. So these are the individual experiments that I basically performed. Now, I am taking this Q. This is Q only. This is Q only. Understand? I'm placing this Q over here. And I brought that Q1, Q2. I'll just make it on the other one. Okay. अरे चलो इधर ही बनाता हूँ. Okay. Forget about these two. Forget about these. The naming is exactly different. Okay. So I'm saying that I'm bringing that same Q over here. Now, what I exactly did, I'll take this Q1. So what's going to happen? You will say simply this will apply the force on this one. I found that this is applying the force F, I would say. Now, I will bring this Q2 also over here when this was present also. Understand? Previously, there were the individual charges they were interacting with. Understand? Initially, this was interacting with this one. After some time, this was interacting with this one. This was interacting. Now, right now, I'm bringing all of these together. They are interacting with this charge. So I'm taking this Q2. So what's going to happen? You will say this will apply the force on this one. I would say this F2. I'll bring this Q3. This will apply the force. This will apply the force on this one. I would say this is F3. Understand? This is F1. So what I exactly found that this F1 was still 10 Newton, this F2 was still 10 Newton, this F3 was still 10 Newton. Like in the previous case, individually this was applying the force of 10 Newton over here, this was applying the force of 10 Newton, 20 Newton, 30 Newton. Here also, when I brought them together, all together, okay, all together, in that case also they are applying the same force. Understand? This is the point number one. Keep this point in your mind. The second point is, if I ask you what is the net force on this charge, you will say the net force on this charge is basically force due to this charge, force due to this charge, force due to this charge. So basically it is the vector sum of all these forces. So can I say F net on this charge is nothing but force due to this individual charge plus force due to this individual charge plus force due to this individual charge. How many charges basically you can bring over here? We'll vector sum all of those forces up to n, understand, Fn up to Fn. So this is what we call the superposition principle. What superposition principle exactly says? If there is a charge, if you introduce any charge, it will start applying force on that one. If you bring another charge, if you introduce another charge, that will also start applying the force on that one. If you bring another charge, that will also start applying the force on that one. And if you want to find the net force on that charge, that will be the vector sum of all these individual forces. Understand? And the most important point, that is, these forces do not change. Understand? They do not get affected on the introduction of the another charge. Like in the previous case, it was 10 Newton. When we brought this Q2, because of this Q2, this force doesn't get affected. Understand? This force doesn't get affected because of this Q1. Everybody understood this one? Drop a thumbs up if everybody understood this one. If not, I'll make you understand once again. Good evening, good evening. Sir, will there be chemistry class for 12th in this channel? Yes, there are chemistry classes going on this channel as well. Yes, they are independent of each other. Yes, they do not get affected by the... Yes, they can exert the forces on each other. We are taking this charge as a sample charge over here. If I say net force on this one, we can also say net force on this one. In that case, these all will be applying the force on that one. Understand? Apply. Yes, Q1. See, what Khushi is exactly saying, sir, why can't this force apply the force? Why can't this charge apply the force on this one or this one with this one? They can. I am basically making you understand. I'm just giving you the example. Consider this charge only and we'll basically check the force on this, because in superposition principle, we basically talk about any single charge. Now, instead of forget about this charge, we can take this Q3. Now, what is the net force on Q3? You will say net force on this Q3 will be because of this one. Net force on this Q3 will be because of this one, because of this one. The vector sum of all these forces. Drop a thumbs up if you got this one. So right now I'm taking this reference charge. Because the superposition principle we are understanding like this only. Because of this, I am saying basically on this reference charge, what are the forces acting? Drop a crystal clear if you got this one. Somebody is saying, sir, will you live more than 100 years to teach so good? Thank you means a lot. Sir, please say my name. I'm Vidya. Hi, Vidya. Okay, that's nice. If this is crystal clear, let me just give you the another feel of this one. Okay, another golden feel. What is that? We say this superposition principle is not valid on nuclear forces. Okay, so what is this force over here? This is Coulombian forces, Coulomb's force. This is valid over here. What it says exactly? The net force on any charged particle because of the different number of charges will be the vector sum of all the forces that is basically applied by these individual charges, F1 plus F2 plus vector F1 plus F2 plus F3. So this is the system over here. Fine. And these forces does not get affected on the introduction of the another charge. Like previously, when we were doing these experiments individually, in that case, Q1 was applying 10 Newton, this Q2 was applying 20 Newton, on this Q3 was applying 30 Newton. When we basically all of them brought them together, in that case also they were applying the same F 20, 10, 30. So this is what a superposition principle exactly is. Yes, Praveen. So Praveen, basically force does not get affected. Understand? If we bring the another charge over here. Okay, chalo. Now, superposition principle is not valid on the nuclear forces. Now, let me just, what are the nuclear forces? Nuclear forces are basically the forces between the nucleons. Understand? Forces between the nucleons which are in the nucleus in order to basically make the nucleus very strong. Because in nucleus, what have you studied this one? In nucleus, there are protons which apply the force, the repulsive force, strong repulsive force on each other in the outward direction. Now, nucleons are in this nucleus, which basically keep them stick together inside this nucleus only. So it is because of the nuclear force. Now, but this superposition principle is not valid on nucleons. It is not valid on nucleons. Let me just give you the feel. For example, see, basically this nuclear force between the nucleons is attractive force. Understand? This is not in our syllabus, still I am saying you. It is basically the attractive force. But when the separation, if I say, for example, this is nucleon, this is the another nucleon. Understand? And N2. If we keep on decreasing the separation between these two nucleons, this attractive force, this nuclear force, which is attractive between these two, it becomes repulsive. Understand? Approximately 10 raised power minus 7 FM. If we decrease the distance between the two, then afterwards it will start becomes repulsive. It is not in our syllabus, still I am basically saying you over here. Now let me just give you the feel of this one. Why is it, how is it not valid over there in that case? See, if I say, for example, there is a nucleon, okay, if I say this is N and I'll bring the another nucleon, for example N1, and I brought them very close to each other, in that case they will start repelling each other. This attractive force will become a repulsive force. Later on somebody will say, sir, this nuclear force is attractive in nature, how can you say this is repulsive? If the distance between these are basically very small, understand? In that case, if we bring them very close to each other, in that case it becomes repulsive. So I would say, for example, this is applying the force of, it's a very strong force. Okay, so if I say, for example, right now I'm just taking your example of 10 Newton in this case. Now I am bringing this nucleon N2 over here and I'll take this N2. This is N nucleon, same N nucleon. I'm bringing this N2. And what will happen? This will start applying the force on this one. I would say, for example, 20 Newton. Now, once again, I'll take this nucleon and I'll bring this another N3 nucleon. This will start repelling this one with a force of 30 Newton, I would say. Okay, 30 Newton, I would say. Now, what happens afterwards? Okay, there is no space. Let me just show you it over here. Okay, fine. So what happens afterwards when we took that nucleon N over here, understand, and I'm taking all of these nucleons over here together on this screen at the same time. What's happening? Let's see. So this nucleon N1 will start applying the force on this one. This nucleon N2 will start applying the force on this one. This nucleon N3 will start applying the force on this one. We observed that the force is not equal to what they were basically applying individually on this one. This F1, because of this it was F1, it was 10 newtons, it is not equal to 10 newtons. Because of this it was 20 newtons, right now it is not equal to 20 newtons. Because of this it is F3, it was 30 newtons, right now it is not equal to 30 newtons. It is something different, understand? Drop a thumbs up if you got the feel of this one. This information you will see nowhere, okay? Nobody is gonna tell you this one. Come on, tell me, drop a thumbs up if you got the feel of this one. Individually, they were applying the force like 10, 20, 30. When I brought all of these together, in that case, these forces basically change. So can I say in this case, superposition principle is valid? No, not valid. Okay, I want all of you to take the screenshot of this one because this won't come in your notes. Okay, because superposition principle tells us exactly that this force doesn't get affected when we bring all of the charged particles together, but over here it is changing. Understand? Because of the other charged particle, this force gets affected. All of these forces get affected. Okay, let me just give you the another feel. That is the mechanics feel. Feel after feel, feel after feel. The mechanics feel. You will love this one, okay? You will love this one. See. If I say, for example, this is a ceiling and this is a string and this is a block over here. If I say this is 50 kgs block, what is the force in the downward direction in that case? Can I say this is nothing but 500 Newton, m into g, mass into acceleration due to gravity? And can I say this is nothing but tension in the upward direction because this string is pulling this mass in the upward direction? See, this is a ceiling, this is a string, and this is a block attached to this string. So this block is basically not going down. This block is basically not going down. If this block is not going down, that means upward force is equal to downward force. That means this tension is balancing this weight over here. Understand? This string is balancing this weight over here. So in that case, can I say tension is nothing but it is 500 Newton. This you might have studied in your class 11, everybody. Now what I'm doing, I'm taking the same block over here. Understand? That is 50 kgs. And how much is the downward force? You will say, sir, 500 Newton. Now, how much is the tension? That is T. So if this is in the equilibrium, this is at rest, means upward force is equal downward force, 100%. Now what I actually started doing, I started pulling this with the, for example, 50 Newton once again. Now, what is happening over here? Now what is happening over here in this case? In this case, I'm pulling this, still this block is in the equilibrium. This is a block, there is a string attached to this block. I'm pulling this block in the downward direction, still it's not coming down. So in this case, can you tell me how much is the tension? You will still say upward force is equal downward force because this block is still in equilibrium. It's not coming down. So upward force is equal downward force. Upward force is tension. Downward force is nothing but 50 Newton plus 500. So tension is nothing but 550. Can you guys tell me in this case, is this tension affected by the presence of, by the introduction of the another force? Yes. Over here on the same block, it was 50 Newton. But after I introduced this block, this tension changed to 550 Newton. Is the superposition principle valid over here? Definitely not. Okay. In this case, in this tension case, drop a thumbs up if you got the feel of this one. Come on, everybody. I need to know in the live chat. Come on, man. Okay. You can get the feel of this one like this also. Okay. Let me just give you the another feel. For example, there is a table and there is a block over here. This is the 50 kg block. And this same block, the 50 kg block over here. Now, could you please tell me how much is basically the mg over here? You will say simply, sir, mass into acceleration due to gravity, 550 into 10, that is 500. So 500 Newton in the downward direction. This block is applying the normal force on this one. When two bodies come in contact with each other, they apply the normal force. So this will apply the normal force on this block in the upward direction. So N, in this case, normal force is nothing but 500 Newton. Can you tell me in this case, how much will be the normal reaction? See, initially in the downward direction, it is 500 Newton. In the upward direction, it is N. So N will be nothing but 500. Now I started pressing this block from the upward direction. It is still not going down. Still not going down. In that case, I am supposing I'm applying the 100 Newton of force on this block. Still, it's not going down. So that means upward force is equal to downward force. In this case, what will be the value of normal reaction? So can I say that is nothing but 500 plus this 100? It will be nothing but 600 Newton. So normal reaction changed on the application, on when we basically introduced this force, 100 Newton force. So here also it is not valid. So these are the enough examples for superposition principle. Okay. I hope you got the feel of this one. Now let's basically move on to the problems. We need to do the problems now. Okay. Drop a thumbs up heart if you got the feel of this one. Come on, everybody. Come on, man. Okay. That's nice. That's nice. So, equilibrium of charged particles. What is this equilibrium of charged particles? See, this is a category of problems that we're going to be seeing in the special class today at 8 o'clock, 8 p.m. I want you people to join me over there. I'll be showing you the next level problems. Okay, next level. You will love all of those problems, and everybody of wood, you will follow that in front of me over there, and I promise you this. Now see. So, equilibrium of charged particles. What is this? We will be basically given different number of charged particles, and on any particular charge, we'll be saying on that charge, the net force will be basically 0. So that is basically the equilibrium of charged particles. You will be basically getting, you'll be understanding this when we have a look on this. In equilibrium, net force on a charged particle is 0. Understand? So this is what we're going to be seeing from the questions itself. Then you will get to understand this properly. Equilibrium. So the first category that we'll be basically talking about, equilibrium of systematic geometrical point charge systems. Let me just give you the feel from the questions itself. Let's move on to the question. So this is the question number 1. I want everybody of you to solve this right now, right here. Can you guys tell me what is the value of this one? A, B, C, D. See, I'll make you understand what is the question. Question says that there is a plus 3Q charge present over here. Understand? And there is a Q charge over here. And there is this capital Q charge over here. Understand? On a straight line, such that this separation between these two is equal. In order to make the net force 0 on Q, we have to say basically on this Q, if we want to basically make the net force 0, force due to this one is equal force due to this one. So if we want to basically make that 0, what has to be the value of this Q? Value of this Q, what has to be the value of this Q that we are supposed to find over here? Come on, everybody. Can you tell me the answer of this question? I need to know in the live chat. What is the answer of this question? See, it is saying that this charge has to be in equilibrium. Equilibrium means net force on this charge is 0. What are the forces acting on this charge? You will say force on this charge is basically because of this force, because of this charge that is in this direction, I call that F. Because of this F1, I call, because of this charge on this charge, it will be in this direction. Both are positive. Understand? All the three are, for example, positive. So it will be basically the force in this direction and the force will be in this direction. So I call this as F2. So in order to make this charge in equilibrium, F1 has to be equal to F2. Understand? F1 has to be equal to F2. So now you can basically solve this question to find the value of this Q. This is basically the hint for this one. So what is the value of F1? Now, what is the value of F1? F1 is basically force due to this one. I'll just change this. I'll call this as F1. I'll call this as F2. Understand? F1 is because of this one in this direction, opposite direction. F2 is because of this charge on this charge in this direction towards the left. Understand? Now F1 is equal to F2. We can clearly solve it in just few seconds. So what is the force F1? That is force between these two charges. Can we say that is K, Q, 3Q upon what is the difference between these two? For example, I say X, this is X, so this is nothing but X square is equal to. The question itself says that it is in equilibrium. That means the force on the right side will be equal to the force on the left side. So can I say from this side, force between these two particles, understand, that is F2. So can I say that is basically equal to K, this Q, Q1, Q2 upon X square. This will get cancelled off. This will get cancelled off. This will get cancelled off. So Q is equal to plus 3Q over here. Option A is the correct option. Okay. I hope everybody got the feel of this one. Yeah, 3Q plus 3Q. Praveen is basically saying A. Let me check. Yeah, nice. Come on. What should be the sign of a charge at fourth vertex? What should be the sign of this charge? So that net force on this charge is 0. Should it be positive charge or should it be negative charge? Tell me in the live chat. Should this be as a positive charge? I'll just write, should this Q be as positive charge or this as negative charge, so that the net force on this charge should be 0? Tell me in the live chat. Tell me in the live chat. Come on. I'm saying you this one. I'm saying you this one. What should be the sign of this charge so that the net force on this charge is 0? Positive. Sambhav saying negative. Khushi saying positive. Praveen positive. Let's check for the positive and for the negative as well. Let's go with the positive first. If we say, for example, this charge is a positive. Okay. If we say, you are saying this one. Okay. If you say this charge is positive. Now look at this charge. Try to have a look at this charge. Okay. Have a look on this charge. So this will basically, this is positive, this is positive, this is positive. You are saying this one is will keep also positive. Understand? Now, this is basically repelling this charge in this direction. I call this as F1. Okay, everybody. Now, this is repelling this charge in the outward direction because both are positive. I will call that F2. Understand? Fine. Now, this is repelling this charge also because both are positive. It will repel it. So I call that F3. Understand? Fine. Now you just tell me one thing. F1 and F2. F1 and F2. These both will have the net along this only. This and this will have net force along this only. So net force, I call that F net. Understand? And already this F3 is in this direction. So how they are basically gonna cancel each other? How will the net force be 0 over here? Tell me. Sir, in the previous problem, why we had not taken the negative sign? Come on, man. Q, K, Q, 3Q. What is this? K, Q, 3Q. This is the force between this one and this one. This is F1 force. Force between this one and this one. Now, this one is the force. In that case, we are taking plus 3Q plus Q. That's why this is plus 3Q over here. Understood? Drop a thumbs up. Or should I make it a, should I tell you this once again? Yeah, this F1 is the force, that is QK, Q1 plus Q plus 3Q upon X square. That's why this is plus Q. So ultimately this remains, na? This Q and this plus Q. That's why this is plus Q. Come on, man. Drop a thumbs up, Sambhav. You understood this? At least tell me no. I'll make you understand this once again. Come on. Chalo. So let's basically check for the negative charge. If we basically place the negative charge over here, if we place the negative charge over here, then let's see what's gonna happen. I'll just show you that over here. For your notes, it will be better. Yes, sir, fine. Khushi, what are you saying? Khushi, what are you saying exactly? Then it's negative. Now I understood once you explained, sir. Now see, I'll make you understand this one once again. Now we are taking this charge as negative charge. This is Q, this is Q, this is Q. Understand? All of these are positive charges. Now see, this will repel this in this direction. I call this F1. This will also repel this charge in this direction. I call this as F2. Understand? Now I'll just rub this. I hope everybody is loving this one. And now in this case, this will basically, this is negative charge, this is positive charge. It will attract this towards itself. I call this as F3. So these two will have the resultant in this direction, F net. Now in this case, there is the chance this will cancel out this one. So we have to take this as negative. Rest, it depends how much it exactly will be. Then we'll check accordingly how much this should be, how much this should be. It will cancel out. We are right now talking about the signs only. What has to be the sign so that they will cancel each other. Okay, about this question itself. Okay, fine, not a problem. Come on. I want you people to solve this question by yourself. Do let me know what is the answer of this question as soon as possible. Can you guys tell me what is the answer of this question? 3 equal charges plus Q are placed at the vertex of an equilateral triangle. Find the net force on third vertex. See what is the question over here. It is saying that this is an equilateral triangle. Okay. So there is a charge present over here plus Q. There is a charge present over here plus Q. There is a charge present over here plus Q. Okay. We are supposed, this is an equilateral triangle. It will be 60. All of these will be 60. We are supposed to find what is the net force on this plus Q charge because of the other charge, because of the rest of the charges. Can you find this? Can you find this? Do let me know in the live chat if you can find this one. Okay. See what you gonna basically do. This, see what, how you will be a pro in problem solving. I'll tell you the simple trick. You just do one thing. Before I solve the question on the board itself, you have to do it. Understand? So that should be the rule over here. When you do that, it will definitely take you to the next level in the problem solving. Okay. Now see, let me just make you understand how to basically solve this. See, this will create the force on this one in this direction. I would call that F1. This will create the force on this direction. I would call that F2. Understand? So this is F1, this is F2. So they will have the resultant like this only. If this is at 60, so this will be 60. So it will go exactly from the center. So I call, if this is at 60, so this will be exactly, I would say this is 30. And between this, it will be 60. Understand? Between this and this, it will be exactly 60. So I'll just mark this as 60. So it will be 60 degrees. Understand? Fine. Okay, let me just find it. So let's find this F1, let's find this F2, then we'll find its F net. Then we got the answer. So F1 will be nothing but Q. F1 is 1. Which one? This one. So that will be Q square upon how much is this? You take this as X. So it will be X square, or simply take it R. So it will be nothing but R square. Okay. So this is R square. And how much will be F2? Can I say that is also KQ square by R square? Understand? This KQ upon R square. Understand? 100%. So F1 will be equal to F2. So I can say F1 is equal to F2 is equal to F clearly from this one. Now if these are equal, so can you tell me what is the net force over here? Can I say F net is nothing but, see, this is a vector, this is a vector over here. That is nothing but F square, F1 square. Instead of F1, I'll just write F only, because F1 is equal to F2 is both are equal. So F square plus 2 F cos of 60 degrees. Cos of 60 degrees. Understand? So can I basically say this exactly? This will be nothing but, this is 2F square plus 2F square, and this will be nothing but 1 by 2. This 2 will get cancelled. So it will be nothing but 3F square. F will just come out, and this will be root 3 into F. Everybody got the same answer? Do let me know in the live chat. Praveen just deleted his message. Okay? Come on. And I want everybody of you to basically like this video. Like this lecture as soon as possible. Okay? Yeah, fine. Let's move on to the next one. Now, I'm exactly doing the same question, but right now what I am supposed to do is I'll just place the negative charge over here. This is plus Q, this is plus Q. Tell me what is the net force on this charge? How much is the net force on this charge? Can you guys tell me how much is the net force on this charge? I need to know in the live chat right now, right here. I'm waiting for your answers, okay? Yes, I exactly used that only. Resultant of vectors, okay? In previously. This F net, understand, or F square is equal to F1 square plus F2 square plus 2 F1 F2 cos of theta. Understand? F or R is equal to, simply resultant R is equal to, that is F1 square, R square is equal to F1 square plus F2 square plus twice F1 F2 cos of theta, where theta is the angle between F1 and F2. So finally R is equal to root of, that is F1 square plus F2 square plus 2 F1 F2 cos of theta. Then you will ask me, sir, why did you take F1 as F, F2 as F? Because previously we have calculated F1 is equal to F2 is equal to F. Now you got the feel. That's why, see, this is the reason you are supposed to join. This is the reason you are supposed to join the live classes, okay? If you have any sort of confusion, you will tell me in the live chat itself and I'll make you understand. Come on. At 30 degree not Sambhav, it's at 60 degrees, okay? Angle between F1 and F2 is 60 degrees. At 30 degrees, it will be the resultant because F1 is equal to F2. That's why it will be along the middle only. Okay. Now, I want you people to follow this one. The same method. But right now, see, there will be a bit of a difference. Now, see, this charge. Now, see, in this case, what's going to happen? So this is positive charge, this is negative charge. It will attract this towards itself. Understand? So I call that, for example, this is F1. This charge will attract this charge towards itself. I call that F2. And this is F1, this is F2, and this is an equilateral triangle. Angle is 60. So resultant will be something like this. F net. Understand? This will also come out to be the same. That is root 3F. And previously, if this was root 3F, I can basically write root 3. What is the value of F? That is K Q square by R square. So in this case, it will come out to be same. That is root 3 KQ square by R square, definitely. Understand? I want you people to solve this at your own, okay? Yeah. Okay, that's fine. That's fine, Sambhav. Okay, I want you people to solve this at your own. Everything is same over here. Now, this is the question. How we are supposed to solve this question? Come on, the next question. So what is basically given in this question? It's saying that there is a charge plus Q placed over here. There is a charge plus Q placed over here. And there is the charge plus Q placed that is exactly at the centroid of this triangle, okay? In this case, this charge is applying the force on this one as a 2 Newton. This charge is applying the force on this as a 2 Newton. You are supposed to tell me, find the net force on Q at the center. You are supposed to tell me what is the net force on this Q. Come on. You are supposed to tell me what is the net force on this Q. If you can solve this, do let me know in the live chat. Net force, Khushi, Sambhav, Praveen, come on. Hurry, come on. This is a bit different. This is a bit different. Come on. Solve this one. What is the answer over here? Option number A, I would say 2 Newtons. Option number B, 3 Newtons. Option number C, 4 Newtons. Option number D, 8 Newtons. Come on. I want you to solve this as soon as possible. Sambhav is saying option A. Sambhav, can you tell me the reason how? Can you just tell me the reason how? And what about the other people? It's very simple, huh? You just have to find the resultant of these two vectors. Understand? We are supposed to find the net force on this charge Q. See, this is applying the force on this one. That will be in the outward direction because this is a repulsive force. It will repel this one. This will also repel this one in this direction. So it is, the question itself is saying it will exert the 2 Newtons of force. This will also exert the 2 Newtons of force. In this case, you are supposed to tell me the net force, okay? In this case, you are supposed to tell me the net force. Come on, what should be the net force? I need to write that over here. Yeah. Sir, did you discuss vectors from form of Coulomb's law? Yes, today's class in the starting itself. I discussed that already. Yeah. Now see, the resultant will be exactly, I would say like this. Now you will say, sir, how to find the resultant over here? So can I say basically resultant exactly it is this one? Understand? How to find the resultant in this case? So I would say F net is nothing but root of, that is F1 square plus F2 square plus twice F1 F2 cos of how much? Cos of how much? Cos of how much? 120 exactly. Why 120? Because when the two vectors are having the same magnitude, that means they will be at an angle of 120 degrees. So I can say this is 120 degrees. So this will be F net is nothing but root of. So F1 is what? That is 2 Newtons. So I'll just write 2 square. F2 is what? That is 2. That is 2 square plus. This will be 2 multiplied by F1 is 2 multiplied by F2 is also 2 multiplied by cos of 120, that is 1 by 2 minus 1 by 2 exactly. So can I just write it will be nothing but 4 plus 4 plus this 2 and this 2 will get cancelled off. This minus will come over here and this 2 into 2 it will be 4. So ultimately I can just write it over here minus 4. This will get cancelled off. So this is a root 4. It will come out to be 2 Newtons F net. Okay, come on, let's move on to the next question. I want you people to find the net force on this charge. Fourth one. This is a plus Q plus Q plus Q plus Q. Every day Mohan comes here in the live chat and asks, sir, when maths class will start, when the maths teacher will come. He'll come, bro. He'll come, bro. Don't worry about that. Come on. Do you have any suggestions basically who should we get on this channel? Who should we basically bring over here? Any suggestions from you? Can you guys tell me what is the resultant of this one? What is the net force? What is the net force over here? See, I'll just tell you the simple clues. This charge will repel this charge with a force. I would call that, this is a second charge, I would call that F2. This will repel this force, I would call that F3. This will repel this charge, I would call that F1. Just you have to find F2, F3, F1. That's all. Understand? See what you're gonna be finding. First find F2, F3. Find the resultant. Add that resultant with this one, because the resultant of these two will be having along this only. Along this only. F net. I'm fine. What about you? No. Root 2F, no. Wrong. I'm asking you the net. Okay, you are asking me about these two. Tell me the total one. So let's find this F2 first. So I'll just find this F2 and I'll just find this F3. So if I say, for example, this is X, okay? If this is X, if this is X, so can I say this is nothing but K, Q, Q. I'm finding F2, okay? K, Q, Q. That is Q square by X square, okay? And what about F3? F3 will come out to be K, Q square by X square also. See, what is this? K, Q, Q by X square. This is also X. Understand? This is a square. This is not a rectangle. Keep that thing in your mind. Can this chapter be studied without gravitation? With gravitation? Yes. We can study this with gravitation, okay? So can we say F2 is equal to F3? Understand? So it will be equal to F only, because both are same, both are having the same magnitude. Fine. Now, the point is we need to find the F net. Let's find the F net. It is nothing but a root of F1 plus F2 plus F3. So I can clearly say that is F square, because this is F only. F2 is F only, plus F3 is also F only, F square, plus twice F cos of 90 degrees, because angle between F2 and F3 is 90 degrees. So I can say clearly over here F net will come out to be nothing but cos 90 is 0. So this will come out to be 0. So this is nothing but 2F square. So it will be F root 2. F root 2. So this is F net. So it will come out to be, what is the value of F? That is KQ square by X square into root 2. Yeah, Praveen, I need to check this one. Yeah, you're right. I need to check, okay? Most probably you're right. Chalo, I need to find this one now. What is the value of F1? See, we got the value of F net. Understand? That is the resultant of this one and this one. Now we need to find this F1. That is this force. Understand? So how much? If this is X, how much this will be? Understand? This will be X root 2. Yes, you might have studied this in your square. If this is A, side of a square is A. How much is this? This is diagonal is A root 2. Understand? Now, if this is A root 2 over here given, so can you find the force F3? So can we just find the force over here? F3 will be nothing but K, Q and Q. That is Q square. K, Q1, Q2. Q1, Q2. That is Q square. Both are Q. Upon, what is the value of R over here? That is nothing but X root 2 whole square, because this is R square. Okay? What is happening? Okay. So, can we just write it over here? This will be nothing but KQ square, and this will be nothing but, this will be 2x square exactly. 2x square exactly. Now we need to find basically the F total. F total, I call that F total or F net, F total at this charge, fourth charge. This is what we are supposed to find. So that is this F net plus this F1. This F net plus this F1. This is basically F1. This F net plus this F1. I hope everybody is understanding. So what is F1 over here? F1 is this one, k q square upon 2x square plus, how much is this? This is k q square upon x square into root 2. So let's move on to the next one. So let's, okay, there is no space exactly. We have to manage it over here only. So finally, I can just write it. It is, so finally, I can just write it. So it is k q square upon, I'll just take this common, k q square upon x square, and it will be nothing but root 2 plus 1 by 2. I hope everybody is able to basically see this one. Can you just see this? I need to check. Can you just see this? I need to check from YouTube itself. Yes. This is 1 by 2. 1 by 2 exactly. Okay? Fine. So this is the answer over here. Everybody got this one? Drop a thumbs up. Yeah. Chalo. Let's move on to the next one. So the same question, but I am placing right now the minus q over here. Understand? I am placing the minus q over here. I am placing the minus q over here. Can you just find the force right now? See, if this is minus q, this will attract this towards itself. This will also attract this towards itself. And this will also attract this towards itself. Understand? So I call this as, this is the F3. I call this as, this is F1. I call this as, this is F2 and this is F1. Understand? Fine. Let's find the F2 and F1 for same approach. F2 will be nothing but that is k q square by x square. F3 will be nothing but that is k q square by x square. K q, that is q square by x square. Difference between this is x and this is also x. That's why x square. So I can say F net is basically, that is nothing but this f square plus twice f cos of 90. So it will be nothing but a root 2f exactly. So this will be 0 and it will be root 2f exactly. So what is that? That is 2 and it will be k q square upon x square. Everybody, now what is the value of this one, this f1? So for that you have to take this diagonal, that is x root 2. It will again come out to be, this f1 will again come out to be k q square by, previously how much it was? 2x square. So when we basically add them, f total will come out to be, that is nothing but how much previously it came, kq square by x square root 2 plus 1 by 2, kq square by x square root 2 plus 1 by 2. I got till f net, then I followed you, sir. Okay, that's fine. You can do it later also. See, minus plus is basically, we are just showing the sign, we are basically showing the direction over here, na? So in that case, you are not supposed to say this is minus q plus q. I am saying you, what is the direction of this force? That is this. What is the direction of this force? That is this. What is the direction of this force? That is this. So using Coulomb's law in vector form tells us the direction as well as magnitude. But forget about that. When we come into the problem solving session, I suggest you to forget that Coulomb's law. Understand? That's just for the understanding purpose or reading purpose. When it comes to problem solving, in that case, you show basically how much is the magnitude there and what is the direction, right? If I say, for example, this is the charge, this is the charge. This is Q, this is Q. Praveen, listen to me. This is Q, this is Q. I'm saying how much is the magnitude of charge? You will say the magnitude of charge is nothing. The magnitude of force is nothing, but this is repelling this force with this force. How much is the magnitude of force? You will say F is nothing but K Q1 Q2 upon R square. Now, direction is what? Sir, this is repelling. So that means this is the direction. This is, if the charges are same charges, so that means this is repelling, repulsive force. If the charges are opposite charges, that means this is attractive force, this is direction. By using this simple logic, you will solve every question. Understand? That's why I am not taking minus plus over here. Come on. Tell me what is the net charge at this Q. Understand? And tell me the individual charge also. Find individual charge also. At this point, how much is the net charge? A is kq square by x square. B is kq square by root 2 x. C is 0. D is kq square by 2x square. My own options. Yes. Yeah, Praveen. How much is, what is the option? What is the net force over here? What is the net force over here? Tell me among all these options. Hari is saying 0. Let me just find. Now see, definitely it will be 0. See, because of this charge, this is a plus q, this is plus q, plus q, plus q. So this will repel this charge in this direction. Understand? So now this will also repel this charge in the opposite direction. I would say this is F1, this is F2. Now this is repelling this charge in this direction with the F3. This is repelling this charge in this direction, I would say F4. So all of these, see, there is the difference between this and this charge is same like the difference between this and this. Charges are same, magnitude same. So obviously this force will cancel, this force will cancel, this force. So option C is correct. So there will be 0. Understand? Now, how much is the individual charge that we're gonna, these two charges are basically creating over here? Let me just tell you. So can I say F is equal to nothing but K, this Q will find just one, rest of the others, then we can find easily K, Q, and this Q upon. How much is this difference? How much is this difference? See, this whole, if I just write it over here, this is a diagonal, okay? If this whole is nothing but a root 2, if I say this is x or a, so this is a root 2. Now, how much till here it will be a root 2 by 2, half of this diagonal. So now I want you to rationalize this by root 2 by root 2. So how much it will be? It will be nothing but 2, so root 2 into 2, it will be 2a upon 2 root 2. This will get cancelled off. So it will be a by root 2. So this much of distance between this charge and this charge will be a upon a root 2. So it will be nothing but a by a root 2 whole square. So it will come out to be, this is a square. It will become a square and 2. 2 will go up. So 2k q upon a square. So this is the individual charge. Come on. Let's move on to the next one. Now there are the other. In the special class, I'll be showing you the killer level problems. These problems are nothing in front of those problems, okay? I want you to basically join me over there. At 8 o'clock is the special class. Now, find the net. Arey yaar. Find the net. Find the net force on this charge which is present over here in center. I would say plus q. Tell me how much it is exactly. You will say obviously it is 0. See, this is repelling this charge in this direction. This is also repelling this charge in this direction. This is repelling this charge in this direction. This is also repelling this charge. There will be this force. There will be this force. All of these will cancel each other. So net force will be F net is nothing but 0. Everybody understood? Now, in this case, could you please tell me what is the net force on this charge Q over here? In this case, there is no charge present over here. No charge present over here. Tell me what is the net force on this charge? I'll just mark the options A such that this difference between this length is basically x. Understand? This length is x. So I would say this A option is basically kq square by x square. B is kq square by x. C is 0, D is KQ square by 2x square. Come on. Sambhav is saying 0. What about the others? Option A, B, C, D. Which option? A, B, C, D. Hari is saying option A. What about the others? What about the others? I'll just tell you the simple trick. Yes, yes. Okay, that's very nice. I just tell you the simple trick. See, this will repel this charge in this direction. So it will be exposed, for example, with the force F1. This will also repel this charge in the opposite direction. I would say, for example, F2. Now, this will repel this charge in this direction. I would say F3. So this will also repel this charge. I would say this is F4. Okay. So this will cancel this one. This will cancel this one. Now, this will repel this charge in this direction, understand, but this will not repel this charge or attract this because there is no charge present over here. So the net force will be this force only, this force only. I call this as F dash. Let's find this F dash. So F dash will be nothing but K Q, that is this Q, and how much is there? That is this Q, understand, upon what is the distance between these two? If this is L, so X, so this will also be X. So it is nothing but X square. So it is nothing but K Q square by X square. So which option? Option number A. Yeah, exactly. So this was all about this lecture. So ladies and gentlemen, tell me, how was this lecture? Did you guys like it? So apart from this YouTube platform, we have our own platform, that is the that is basically the Unacademy's own platform, in which you can take the Plus subscription, you can take the Iconic subscription, understand? And okay, you can text me on Instagram, Unacademy, Facebook. My username YAWAR MANZOOR or ZOOR, whatever you say it. It is already 7:27. 1.5 hours of lecture it was. Yes, it was interesting. Every lecture of mine is interesting actually. Okay, so you will be getting the live classes, weekly tests, unlimited access, structured courses. And in Iconic, you will be getting all these benefits, and you will be getting the personal guidance, test analysis, experts guidelines, study material, study planners. Awesome. And all of you like this video. I want you people to like this video before you leave it, and all of you comment down below if you like this video seriously, okay? If you seriously like this video, you can comment down below once I end this live stream. So let's move. And you can definitely follow me on Unacademy. This is my username. This is my username on Insta as well. This is my username on Facebook as well. Everywhere, this is my username. You can definitely contact me. And this is the IIT JEE Iconic subscription. If you take it for 12 months, 18 months, 24 months, you'll be getting the branded notes that will be delivered to your doorstep. Understand? That too in the PDF format. Next, we have this IIT JEE Plus subscription. If you take it for 12 months, you'll be getting 2 months of extension. If you get it for 24 months, you'll be getting 2 months of extension. And in this Plus subscription, you can take it. This is the price for this one. This is the price for 18 months, and this is the price for 24 months. By using my code, this is my code, you can get the maximum possible discount. You can definitely get the maximum possible discount. Yes. Yes, sir, but I want apple of your garden. Okay. And this Iconic, you can take it for 12, 18, and 24 months. And these are the batches which are running in Unacademy right now. You can definitely enroll in any of these batches. So this is the Unacademy Combat Scholarship. Unlock this one by using my code. And this is the Crack Unacademy Prodigy Scholarship Test. You can go for this one as well. If you find any of my content as inappropriate, you can definitely report. The link is in the description below. Thank you so much. It was nice interacting with you. And subscribe to this channel. Hit the bell notification. Like this and share this. Yes. Yeah. We'll definitely kill it. So at 8 o'clock exactly, there will be my special class on Unacademy Plus. I want you people to join me over there as well. Okay. So till then, bye-bye. Take care. Thank you so much. Like this video and comment down below. Thank you. Okay. So I need to end this live stream right now. And I'll be sharing the PDF notes. Okay. I'll be sharing the PPT on the Telegram right now itself. So join my Telegram. Okay. Thank you so much.